The primary concept or objective of dimensional analysis is to convert the value of a physical quantity from one system of units to another. Some measures of physical quantities include the primary fundamental qualities such as mass, time, and length. And additionally, it's important to understand the primary fundamental qualities because they assist in deriving the secondary fundamental qualities such as speed. Speed works as the secondary fundamental quality because in order to find the speed of an object, the distance has to be divided by the time, which can be seen in this example. As a whole, dimensional analysis allows for the conversion of one different type of unit to another. Let's take a look at the following example. An example we can use dimensional analysis is in understanding the number of yards there are in 10 feet. We can approach this problem by knowing that 3 feet is equivalent to 1 yard. We're going to go ahead and put the information that we know at the bottom of our workspace. We are now going to go ahead and use dimensional analysis to convert feet into yards by using the conversion factor that we had beforehand. So we know that there are 10 feet that the problem has given us and that there are 3 feet in 1 yard. Now we're going to divide the 10 feet by the 3 feet and understand that there are 3.33 yards in 10 feet. Let's take another example. This time, it's going to be a more chemistry-focused example and be focused on the volumes of liquids because I know that that's what we work with a lot, especially in Gen Chem at UGA. So here, we're going to convert 25 milliliters and see how many liters are in there. If you're feeling up to the challenge and think that you understand the concept, feel free to pause the video at this point to see if you can figure out this problem on your own. Okay, now let's get into the solution. First, let's write down our starting measurements. Here, we have 25.0 milliliters. Sometimes the units that we have will have both a numerator and a denominator, for example, meters per second, but if not, we can just have the measurement be over 1. In order to not change our initial measurement of 25.0 milliliters, but only change the units, we want to find a way to multiply it by a value of 1. In order to do this, we're going to need to find a conversion factor that'll cancel out the ml units that we already have, since we're moving away from those units, and introduce liters, the final unit that we're moving towards. Because we already know that ml means milliliters and that the prefix milli means 1,000th, what conversion factor do we think we should be using? Yes, exactly. We're going to have 1,000 milliliters is equal to 1 liter. Now we're going to plug that conversion factor in. Now that we have our dimensional analysis set up, we can cancel the ml units because we have 1 in the numerator along with 1 in the denominator. And now we see that the only units that are remaining are liters, which is our final destination in this unit conversion. Now all we need to do is follow through with the multiplication and division of the numbers to get 0.025 liters. And that should be it. You have your answer. And this concludes our video tutorial of learning how to do dimensional analysis in Chem 1211. Thank you.